We already know that this hormone plays an important role in the growth of your body. Well, growth is an overly complex process and requires the coordinated action of several hormones. Growth hormone performs its major role in stimulating the body growth in two ways. It either directly affects the target cells or it stimulates the liver to release another hormone called the IGF-1. Growth hormone acts through JAK-STAT pathway. It binds to GHR receptors. This leads to the phosphorylation of JAK proteins. That in turn phosphorylates the STAT proteins. The STAT proteins move in the nucleus where they cause production of IGF-1 through transcription and translation. IGF-1, insulin-like growth factor 1, is a hormone which is necessary for mammalian development. It will act as a mediator to invoke different physiological effects in the target regions. It has two targets, the muscles and the bones. When it binds to the receptors on muscles, it increases the uptake of amino acids and uses them to increase the muscle growth. The end result is increase in the muscle size along with the decrease in amino acid level inside the blood plasma. Inside the bone, it specifically interferes with the two types of cells, osteoblast and osteoclast. It increases the activity of both these cells. We know that osteoblasts are involved in bone formation and osteoclasts are involved in the bone resorption. The bone mass will be increased due to increased endochondral ossification. In the cartilage, it produces its effects through collagen, proteoglycan, and chondrocytes. It increases the collagen type 1, that is important component of the bone and cartilage structure. Proteoglycan is a protein that increases cartilage regeneration and improves bone metabolism. IGF-1 increases proteoglycan level and thus increases the bone growth. It is also involved in the interstitial growth as it increases the differentiation, proliferation, size, and concentration of chondrocytes. Growth hormone itself can play both of these roles by directly binding to the receptors on bones and the muscle. Apart from this, adipose tissue is also the target of growth hormone. Due to its anti-insulin effect, it increases gluconeogenesis in the liver that increases the level of glucose inside the body. It does so by its action on adipose tissue. There it activates the lipases that break down triglycerides. Breakdown produces glycerol and fatty acids. Glycerol is used for gluconeogenesis by the liver. So at a glance, the growth hormone stimulates differentiation and proliferation, increases the glucose uptake and protein synthesis, decreases the lipid formation. Like every hormone in the body, it is important to maintain the homeostasis. This is done via regulatory pathways. Let's see what those are in the next section.